Okay, good morning. We are going to start our class. This morning, we are going to move from descriptive statistic or relationship. We are going to talk about statistic today. Okay, now, if you recall, what is our definition of business analytics? Is to turn the raw information into useful information that we can
useful.
into make good decision, right?
Yes.
Now, we talk about descriptive for a while, and we have talked about how we can describe the data in tables. We describe on graph. We also use numerical measurement. That depends on the types of data. Are you following? You can say okay or no so that I know.
Okay, yes.
Okay.
Now,
Okay.
now when we do all that, we only describe the sample that we have. Okay, for example, you have 200 data about the height of somebody or of the people that you selected. Okay, you have the height of 200 people, and that 200 people had different height. So you describe them in terms of what is the average height, what is the standard deviation, or if you want to use median, mode, and so on. You follow?
Yes.
Now, what happened is, let's say, now we have a data of income for everybody, our sample. Okay, so we have a sample. We have a sample of 200 people. Okay, and these 200 people, the income, the average income, okay, average income is X bar, is say 4,000. Right? Can we say that this average reflects the income of the whole Malaysia?
No.
Can we say that we have an average income of 200, average income is 4,000. This can reflect Malaysia. Okay, so what we do is okay, so now I'm with the new screen, right? So what happened is that we may be able to say yes, this 4,000 average for our sample, but we cannot be sure this represent population. Okay. Now, before I move on, let me just draw this for you. We have, this is our population, and from our population we take a small sample out. So this is our population. So we take a sample out. So our sample of n is a sample size 200 that give us X bar equal to 4,000, right? Okay. Now we can only say that this 200 can represent the population if we do a random sampling. However, no matter how random you do, you still have bias. So the actual population average may be higher than 4,000, may be lower than 4,000. Can you follow?
Yes.
So let's go back one step. I give you another whiteboard. Okay, let's go back one step. Let me define what is a population and what is a sample punya the two terms we use. So if we have a sample size, population we use capital N, and sample we use a small n. And if we talk about the average, okay, the population we use what we call as a mu. Okay, mu is pronounced as M-I-U. For sample, we have X bar. Okay. Now for standard deviation, for population, we have a sigma. And for sample, we have S. So this is the term that I'm using. Okay, when we talk about sample, talk about population, talk about sample. So you have a capital N refer to the size of population, small n refer to the size of a sample. The average will be mu refer to population. Average for sample is denoted by X bar. Is everybody clear?
Yes.
Yes.
Okay, now let's go to the new whiteboard again. So just now I say this is our population and we take a sample out. So this sample, the X bar is $4,000, 4,000 ringgit, sorry, 4,000 ringgit. Why we don't take the whole population? Why can't we study the whole population?
It's too big.
Yes, it's
Too
too
large.
large. So what is the problem with big and large? Anybody? What is the problem with the number is too large or too big?
The number is too large.
Okay, so if it is large, we have two issues. We have two big issues. Okay, the big issue that we have is, one big issue is that our sample is too large. It will take too much time. So we have time issue, and we also will take a lot of cost. Okay, so we have time, we have cost problem. Okay, so when we study the whole population, we call this census. Okay, we call this census. Okay, or in Malay we call this banci. Okay, so this census is done when we really need it. For example, Malaysia have population census once every 10 years. Why is it so? Because we need to have, we need a lot of money. We spend a few hundred millions and it take a long time. Okay, it may take about 1 year or 2 years to collect data, or 1 year, then we have another 2-3 years to do the data analysis and then write the report. After 5 years only we can get the report. So it takes a long time and it takes a lot of cost. Okay, so therefore we do sampling. We do sampling. Okay, so this sampling here, we allow you to take one sample out, and then from the sample we generalize. Okay, if you understand, generalize it to the population. That means we take a sample of 200 person, and the 200 person has a average income 4,000. Then we say Malaysian average income is 4,000. You understand what I'm saying?
Yes.
Yes, yes.
Okay. Now, what happened is that if we do that, we may be underestimate or overestimate the average. You agree? Maybe the sample we take are a lot more poor people. That's why it's 4,000. So if we take a little bit more rich people, then we overestimate. So it may be underestimate, overestimate. So what we do is, if we have the population, we take one sample out. So there is X bar 1. We take another sample out. This is X bar 2. We take another sample out. There's X bar 3. We take another sample out. It's X bar 4. So each sample we take, we have an average. So if we have 100 samples, and each one has an average, and we average out all these. Average out all these and divide by 100. Do you think that this will be closer to the population average?
Closer to yes.
You take it many times. So each time, the first time you take is a sample 4,000 average. Second time you take it 4,001. Third time 4,002. Third one 3,008 and 3,009. So then after that you average out all these sample averages, do you think it will be closer? Okay, so this one will be closer to, let me write this on the whiteboard. So all the X bar divided by 100 here will be very close to the mu. Do you think it makes sense to you?
Does make sense?
You take 1 time, 2 time, 3 time, 4 time, 5 time. Maybe you take 1,000 times. It will be very close to the average of the
Same.
they're making a lot of noise. Who's that? Hello? Is having problem with the speaker? Husna, Joe,
Yeah.
Izan,
Doctor.
are you making a lot? Who is making a lot of noise?
It's
Sure.
Faiz.
Faiz, are you okay? Faiz?
Faiz, are you okay?
Faiz bunyi kipas.
Okay, kita mute Faiz. Mute Faiz, ah. Kita mute Faiz. Okay, now let's go back to our whiteboard.
Weh.
Now,
Faiz kat mana ni?
you may ask me, so what is happening? You know that if we take if we have a population, and we take so many sample, isn't it this the same as doing like a census? It's still costly, it's still very expensive, and it still take time.
Yeah.
Does it make sense? For us to take 100 time or 100 time sample,
Yes.
you understand what I'm saying? It's true. If you have 1,000 time X bar average in it, 1,000 time, it will sure be closer to the mu. It sure be close to the mu.
Okay.
But there is something beautiful and something beneficial from this concept. So this is the concept, what we say, this concept is called sampling. Sampling distribution. Okay, so what this sampling distribution say is, if you plot all these averages into a graph, okay, let's say 3,900. So what is the frequency? 3,910, what is the frequency? 4,000, what is the frequency? So you plot that into a frequency table. The 1,000 averages, you plot this into a frequency table. So what will you get? So according to sampling distribution here, and if you plot all this into a graph, and using this what we call central limit theorem, central limit theorem, central limit theorem says as long as your sample size is more than 30, when you plot this average, it will have a normal curve. That means here, the middle here will be all the averages of the X bar I will be equal to mu.
Okay.
Okay. So what? Okay. Okay. So what? So it means that if you plot this, it will have a normal curve. Okay, now I don't know what happened. Okay, now I know. So this is the normal curve, and here the middle part here will be the mu. Okay. So this is what sampling distribution are all about. This is why you have heard before the lecturers, when you do research, they tell you you must have sample size more than 30. Have you heard that before?
Yes.
Yeah. So they'll tell
Yes.
you must have sample size more than 30. So if you're more than 30, then when you plot it, then you will have a normal curve. So what's so good about normal curve? Okay. Now, a normal curve, if you have a normal curve and if you have a standard deviation, one standard deviation, that means let's say your average is 4,000 and your standard deviation is 100. Okay, so when I say is one standard deviation, that means between here and here, here will be, the middle one will be 4,000. The first line here, this one will be 3,900, and this one will be how much? 4,100, right? Okay, so between here, this will cover 68%. Okay, 68% of the population. You understand what I mean?
Yes.
Okay.
Okay.
I mean, that's still 68%.
Okay. Let me show you a graph here. If you look at this graph, let me share with you, share screen. Okay. Look at this table. Can you see this table?
Yes.
Yes.
If you have a normal curve and it has a one standard deviation covers 68% of the data. If it's two standard deviation, it covers 95% of the data. If it's three standard deviation, it covers 99% of the data. So this is what we call empirical rule.
Empirical room.
Rule.
Go back to my board. Okay. So you have like this. So one standard deviation cover 68%. Two standard deviation cover 95%. Three standard deviation cover 99%. So this is what we call empirical rule.
Empirical rule.
So if you can change your distribution into a normal, then a normal empirical rule. Empirical rule means this rule is always the same all the time. If you test and test again, it's always have the same rule. Okay. So what? So what am I talking about all this? Okay. We take one sample size of more than 30 and we take it repeatedly many times, and we plot the frequency table into a frequency distribution, then we get a normal curve. With a normal curve, we can apply empirical rule. Now, for example, let's say now we want to measure the height of everyone, and on average, we have height of 1.6 meter. Okay. We have average of 1.6 meter. And so we have an average of 1.6 meter. Okay, let me put this on the whiteboard. Average 1.6 meter. And we found that the standard deviation, or the S here, is S R. So the standard deviation is 0.1 meter. Okay. So when we have X bar plus minus 1 standard deviation, it means that you have a range between 1.5 to 1.7, right?
Yeah.
So if we can represent this to Malaysia, we can say that the Malaysian people height, 68% of Malaysian are height between 1.5 to 1.7. That is what empirical rule tell you. So if you have 2 standard deviation, okay, if you have 2 standard deviation, okay, if you have 2 standard deviation, so you will be 1.4 to 1.8. All right. So this will cover how many percent of the people? 95%. So if we have 3 standard deviation, okay, we have x bar plus minus 3 standard deviation, it will be 1.3 to
1.9.
1.9. So this will cover how many percent according to empirical rule?
99%.
9%. So what does 99% mean? It means that the whole population of Malaysia fall within 1.3 to 1. Therefore, we can make a decision. If we want to build a door that will allow 99% of the people to go through, we can build, let's say, 2 meter height.
Doctor,
Yeah.
how do you get it?
Huh?
How you get it? The 1.6 until 1.9? How to count it?
So, okay, we assume that the X bar is 1.6.
Okay.
1.6, standard deviation is 0.1.
Okay.
Okay, so if the average is 1.6, standard deviation is 0.1. So if it's 3 standard deviation, okay, 3 standard deviation means it is like this. Okay, so the middle part here is 1.6. So 3 standard deviation means there are 3 times, right? So each time is the standard deviation is how much? 0.1, right? So it will be X bar plus and minus 3 times standard deviation. Izan, can you get it? 3 times 0.1 will be 0.3.
Oh, okay.
1.6 minus
To me.
6, you get 1.3 here, and here plus 0.3 will get 1.9 here.
Okay, okay.
So the whole thing here, they say here is according to empirical rule, this is 99%.
9%.
You understand?
Okay, yes.
So 99, then we can make a good decision. The decision that we make is, now if we want to build a door, okay, you want to build a door, my door, you can see my door. Okay, you want to build a door, you don't need to have, you want to cover everyone, everybody can go through. Who is talking? I can mute. So what you do is, if you need to talk to somebody outside the class, you can mute yourself. You tekan mute, then everybody won't hear what you're talking about. So once you are ready to come back, you unmute. You understand, Shami? Shami, are you with us?
Yes.
Okay, so if you need to talk, I won't stop you. Just like if you want to go to toilet, you want to go, just mute, or you want to stop a video for a while, you go and come back. Just like in our class, you want to go to toilet, you just go out for a while and come in. Okay, so this is, assume this classroom, this is a real virtual classroom. Now back to here. So this is 99%. Can you see?
Yeah.
Okay, now, so what? Okay, so we are saying that now back to the back to okay, now where is my all my whiteboards dah hilang? Okay, back to here. We have the population. We take many samples. And we can build a sampling distribution. Okay. So once we have built the sampling distribution, now we can now guess this is the mu. However, using central limit theorem, ada dua theorem. We need to stop for a while because we have reached 40 minutes. So take a break, then we'll come in again.
In 10 minutes time.
Yeah, okay.
All right, thank you.